Hey, what's going on, everyone? Hello from Colorado. Happy Friday. All right, let's see who we got coming in. If you're joining us, feel free to say hey in chat if you feel so inclined. I'm Josh. I think many of you have seen me before, but I'll be hosting today. I'm signing in from good old Colorado. Sebastian, welcome. Smitty, glad to have you. Waleed, same wishes to you. Thanks for joining us again. Always a pleasure to see you, Waleed. Steve, hey, how's it going? Howdy from across the pond over here. Maz, hello. Martin, hello from the Netherlands. Awesome, welcome. Maddie, welcome back, as always. Jess, how's it going? Felipe from Paris. Hey, Felipe. Thanks for joining us today. Haim, hopefully I'm saying your name right, Haim, or at least close, from Israel. Welcome. Zaslot, I might have butchered that one. I apologize. From Finland, welcome from Finland. Really great. Glad to have you with us today. All right. We've got Tim Downey in. Welcome, Tim. Robert, Dublin. Glad to have you, Robert. Another person from across the pond. Phil from New York City. Hey, Phil, how you doing? Thanks for joining us. Hoping you're safe out there. Pedro, happy Friday to you too. Thanks for joining us. Thorsten from Germany. Hey, Thorsten. Welcome. Karthik, glad to have you. We got Vivian from Munich. Sweet. Grigor from Moldova. Awesome. Welcome. Phil, Tim, hey. Glad to see you, Timmy, as always. Uday, hey, how's it going? Yash from India, welcome. Meester from Agile Defense, welcome. Juka from Helsinki, welcome, glad to have you. Hey, Michael. All right, we've got Sahad, welcome, Sahad. All right, let's get into some of this stuff, and then I'll check back into chat and see who else is joining us. So if you're just joining us now and you feel so inclined, feel free to say hey in chat. Super glad to have you all here. I'm really excited about this episode. It's a topic that's been, I've had lots of conversations recently about for random reasons. And as you might know, Duffy did some really awesome episodes on this topic. I don't know if you're in the chat, Duffy, but if you remember the date, it was maybe a year ago. I don't know if it's been that long, but I think it was like episode 65, 66. We'll add the episode numbers inside of the chat, the show notes in the HackMD. But, some things have changed, right? And I think there's a lot of really cool things going on in the secret space. So we figured, hey, let's kind of cover it again. We'll talk about what's new. We'll review what's already been covered, and all that good stuff. So I'm super psyched to have you all with me today. And let's just take one more look and see who else we have joining us. All right. Wow, there's a lot of people today. Great. Welcome, everyone. Trying to remember where I left off. Sahad, welcome from Kashmir. Welcome, Robert. We've got Yigit from Turkey. Brandon, Ann Arbor. Hey, Brandon, thanks for joining us today. Glad to have you. Vincent from Scottsdale. Welcome, Vincent. Caleb, Charleston, South Carolina. Sorry, not North Carolina. Hey, Caleb. Brad, hey, how you doing, Brad? From Virginia. We've got Rodolphe. Awesome. I'm ready to learn too, Rodolphe. So we're in the same place. Awesome. Dan from Toronto. Hope you're doing well too, Dan. We've got Chams from Tunisia. Hello, glad to have you. All right. Ansu from Paris. Welcome. Got another person from Paris. We've got Olav from Denmark as well. Awesome. Wow, we have a lot of people from all around the world today. Hope you all are super safe out there with all the craziness that's going on. But maybe we can take our minds off that a little bit and talk about some Kubernetes. How's that sound? So week in review. What do we got going on in Kubernetes land? Anyone in chat played with 118 yet? I'm curious. Let me know in chat if you've tried out 118. Around 118, 118.1 is out. And George, as always, went through and gave us some really cool links to some cool blog entries you should check out. I'm just going to high level go over them real quick. One is around API priority and fairness alpha. This is super, super interesting. My take on it is it kind of lets you put sort of like quality of service type things into the control plane. So you can basically say, what gets priority inside of their communication with the API server. There's a couple ways that you can match the request based on what you're requesting for, what the verb is. I think there's even ways to do it from like the account that's requesting it maybe. I haven't looked too deep into this. It seems like one of those really cool features where if you're running at like a pretty large scale and your API server is getting hit pretty hard from things all over the place, this could be kind of a cool thing to check out, especially over time is like, we have more and more services in the cluster that are talking to the API server. So this is a really cool set of knobs that you should read this blog post on when you get a chance. Server-side apply, just a small mention if you haven't checked out server-side apply. This does a lot of really cool stuff, but it kind of does some of the diff evaluations server-side, I guess you could say. One of the cool things that's intriguing to me, and I haven't gotten the chance to check it out myself, is that it opens up the notion of being able to represent what the fields are managed by, which is always super interesting because you have all these fields in a manifest that might be mutating inside of the cluster from certain things, or might be mutating from your applying and changing of manifests. So this is a really cool one to check out. I'm looking forward to it. Other ones that we've got, there's a topology manager, kind of cool. I don't know how much you all are familiar with like NUMA. But it stands for, where is it at? Non-uniform memory access. So if you've ever looked at like a server before with like a multi-CPU architecture, there's all these different RAM slots, and there's this notion of like ones that are local to that socket group. And then there's the other ones too, that it can basically go through this inner socket connection, which is pretty low level. The cool notion about this is this adds this idea of topology, where the simple way that I think about it, at least for now until I dig in, is like you can use topology to kind of dictate where you're going to schedule something to make sure that it kind of lands in a place where it can access that localized memory. So basically ensuring that you can have, the least amount of latency possible, the most efficient workload possible. GPUs fall under this NUMA category. NICs do as well. Again, making sure that you're not adding extra latency by not using the hardware that's available localized to the socket. So another really cool one, probably really in the weeds for those who are trying to squeeze that memory out. I'm guessing Topology Manager, especially for like GPU use cases, could be especially interesting and cool. So really sweet. Ingress API improvements. This one is interesting. I think the two big takeaways, here they are. Path type, which is a field that will let you specify how ingress paths should be matched. And then ingress class, which is going to specify how ingresses are implemented by controllers. So this is one that's kind of near and dear to my heart. A lot of customers I work with, they'll run multiple ingress controllers. Like some will use a model where they'll tell development teams, hey, just deploy your own ingress controller and run it. Some platform teams offer like a kind of layer of ingress as an inbound access. And sometimes even platform teams will offer multiple ones, right? They'll say, I'm going to run Contour and Nginx and Traffic side by side for a variety of reasons. Now, what ends up happening is you have this complexity of how does the controller know what ingress to satisfy, right? What ingress belongs to it. And you get a lot of variance because some controllers would expect a specific annotation. Some controllers would expect some different qualifier. So I think what I'm most excited about is this notion of ingress class, where you can kind of specify the controller responsible for it. And then inside of here, you can see that we have the ability to reference the ingress class name as well. So yeah, pretty neat. Overall, kind of a cool feature. All right, what do we got going on in chat as well? Some conversations around debug pod. Yeah, cool. Sounds good. Tab died. All right, cool. Awesome, good conversations. I don't think there's anything I need to add to. Looks like Duff's got it under control in chat. And then there's also a post on Windows CSI support. I don't know a whole lot about this. I'm not gonna lie. It's super interesting. It's really cool that the kubelet that runs on Windows nodes will have the ability to leverage that same storage interface to provision things. I'm trying to find the graphic that kind of showed it for me. Here we go. The kubelet exe, and then the underlying Windows host of provision storage. So if you are running workloads, again, these are workloads on Windows nodes. This could be a really cool one to check out. And it's just great to see the health of the Windows community in Kubernetes, and that they're kind of really moving along with a fast follow around CSI compatibility and all that good stuff. So really, really neat. Really neat piece. Yeah, and to Waleed's question in chat, I'd also be super curious. Who in here does use Windows nodes? Does anyone happen to use them in production? I haven't personally run into a use case where a customer was running Windows nodes in production, but I have a lot of customers ask me about it a lot, right? So I think it's on the horizon. I just personally haven't used it much. Yeah, so cool. All right, good stuff. Okay, what else we got going on here? So the working group for resource management has come to an end. It's met its goals. It seems like the notion as well, and I haven't been close to this working group by any means, but it seems like a big thing is a lot of the work that is going to kind of continue on has been subdivided into other more specific working groups. So just an FYI, if that's a working group you were at all involved with or working with. And there's also, until at least April 14th, so we're getting close, an application form if you'd like to shadow the 119 release. So do check that form out. I think it's probably just a Google form. Let's check. Yeah, so release team shadow application. If this interests you, get more involved with the Kubernetes project, kind of get an idea for how these release things work. Someday I aspire to do this myself when I get just a tiny bit more bandwidth with customer work, but it would be a really cool experience to kind of see, how do all the cogs work together in this massive machine of Kubernetes release. So awesome. All right, and then also, if you want to join Kubernetes office hours, they are April 15th. This case, it'll be next Wednesday. We have links in the HackMD for the EU session and the West Coast US session, so be sure to check that out. So lots and lots of cool stuff in the news this week for the K8s core. Now, the ecosystem bits as well. Let me just kill off my Slack before I get notified endlessly here. There we go. Okay. So let's talk a little bit about the Kubernetes ecosystem. So one interesting article that came out of HubSpot was migrating Zookeeper into Kubernetes. So their use case is pretty interesting in this article because they did it without downtime. So as I understood it, reading through it quickly, Zookeeper runs on VMs, right? They wanted to run the Zookeeper nodes inside of Kubernetes, but basically kind of bring them into Kubernetes without introducing a switchover or downtime. So they did some kind of cool stuff in here where they talk about how they took the Kubernetes service and Kubernetes endpoints, really the Kubernetes service, right? And they had that going through to an endpoint. And that was kind of a level above the Zookeeper instances. So basically, Zookeeper, the white box here, is still running on like a VM, as I understand it, right? But there's this kind of abstraction where clients could take this path in going through these Kubernetes services. So then they take the Zookeeper clients, and while Zookeeper is still backed on the virtual machines, they have the clients go through the services and endpoints, which is, again, pretty cool. Just kind of routing through business as usual. And then what this enables them to do is over time, they can then have Zookeeper itself communicating through these services and endpoints. So kind of neat, right? Like they really leaned heavily into that service abstraction in Kubernetes and made it so that it was all working in this Kubernetes networking model. And you probably can guess what's next. Kind of similar to etcd. I'm not an expert on Zookeeper by any means, but the general notion is you want to make sure when you add a node, it reaches consensus, right? So basically, you can swap out one of these Zookeeper nodes with a Kubernetes pod running Zookeeper, and then the consensus can kind of build up in this flow. And as far as the clients are concerned, right, it's business as usual. They're talking to Zookeeper. They don't know whether Zookeeper is running in a pod or running in a VM. So then they basically had Zookeeper running inside of Kubernetes, which is kind of neat. So yeah, I thought this was really interesting. It again just shows like the genius ideas you can come up with if you just really think through like, how can I use these Kubernetes primitives to really benefit myself, right? So we also have some Hacker News comments in here too. Check those out. Had some interesting insight. A lot of times when you talk about things like Zookeeper and Kubernetes, my experience is that folks will kind of get into this political debate about should you be running Zookeeper at all? Like, and the thing that I always tell people, and I work with my customers, is there's nothing wrong with Zookeeper. It's great. Like maybe you have a bunch of apps that already integrate with it, right? Maybe you don't want to change the world and boil the ocean. Maybe your Kafka system integrates with it really well and you're happy with it, right? We love etcd because it's the data store, the key value store, if you will, for Kubernetes, but it doesn't mean that applications have to use it too, right? It's just really kind of cool to see how a lot of these workloads, things like Zookeeper, you can run them super well on Kubernetes and keep a flow that your developers are somewhat used to with their applications. So pretty cool stuff. I'm going to check chat one more time here. What do we got going on? Alex, hey, welcome. Glad to have you. Scotty, nice to see you, Scotty. Welcome. Cool. All right. Yeah, Steve, Kafka and Zookeeper for Kubernetes for 2 years now. I just finished an engagement with a customer, actually, where that was one of their primary use cases was Kafka in the cluster. Now, Steve, I'd be curious, just for my own knowledge, are you able to disclose how you run Kafka? Are you using that, is it pronounced Strimzi, the Kafka operator, or are you using like a Helm chart or something like that to run Kafka in the cluster? I'd be curious. All right, so let's see what else we got going on here, too. Service Mesh Interface, intro to Service Mesh Interface in the CNCF. So pretty cool. I got to do my homework on the SMI or Service Mesh Interface, but love the notion with the emerging service meshes that we're starting to standardize behind an interface. All the people that are working on this, thank you so much for helping us build, kind of the consensus around this. It seems like we have this progression quite constantly with Kubernetes, right? It's like, if you remember back in the day, like we started building these networking tools and then we were like, okay, now let's do CNI. And then storage started happening and we all started doing storage. And then all of the sprawl was happening with how you achieve storage. And then CSI finally came out. And the convergence around these specs has been hugely beneficial in making sure we can understand how a lot of these different plugins work. So check that out if you get a chance. What else do we got here? So Docker Compose has their specification published, so could be an interesting read for you. All in GitHub here, really deep into the weeds. Always cool to kind of see, spec docs and how people are thinking about these plans, and especially for something like Compose that got a lot of adoption, what the spec looks like and what they're implementing against. There's another Kubernetes visualization tool that's kind of interesting, Kubevious. When I read it, I want to keep saying Cube Envious for some reason. But this one is kind of interesting. It looks super interactive. So good job on the UI folks who are working on this project. It's kind of cool. Like, let me see if I can find the picture I was looking at before. It's got like a bunch of columns and almost, yeah. See, so you've got these different columns. You've got, like in this case, they represent namespaces. You can click on stuff. As you click on it, it shows up in the side here. I think one of the really cool things that this is doing, which I'd love to see in more and more of these Kubernetes visualization tools, is it's proactively warning you about things, right? So you can see like the little radioactive sign. I think that might represent overprivileged workloads. They have time machine functionality to show you how things have changed over time, which is a pretty neat idea. I'd love to know how that's implemented. How do you kind of keep all that history? But it's a pretty cool tool. Now, I will say this is a tool that you'll deploy to your cluster, and as a client, you would go use, right? So it's not like if you've ever used something like Octant, where you run it locally. This seems to be more of like a centralized Kubernetes dashboard, if you will. So definitely a neat one worth checking out. Okay. Couple more here. So Argo CD has been accepted into the CNCF. If you use Argo CD, little clap for them. Great job, Argo. Really awesome how a lot of this GitOps and kind of new age deployment models are starting to make their way into the CNCF. And then last couple ones we have here too, Sidekick. So this is kind of an interesting take. It comes from the Minio group on running a little sidecar load balancer that can load balance and do health checks and things like that between pods. So the way that I think about Sidekick is it's not like you would deploy a full-on service mesh, right? It mostly just solves that kind of little sidecar load balancing concern, where it can understand where it can send traffic. It can make sure that it can avoid sending traffic if the health has failed of that thing downstream that it might be sending to. So pretty neat project. I'll be kind of curious to see how some of these more lightweight, let's call them like, I don't know if service routing is the right way to put it, but kind of like lightweight proxy / service routing projects kind of pick up as a lot of the like larger, kind of heavier weight in some ways, service mesh projects are evolving as well. So pretty interesting stuff from Minio. All right. And this was a really cool one from George too. If you're really interested in just taking your virtual backgrounds to the absolute next level, actually like 7 more next levels, Ben the Elder put up this really cool post about how you can go in and modify how these backgrounds work. I'll give you the too long didn't read. You can take a background like this, right? And you can basically have it do crazy stuff like, in his very last post here, have you as a human come in all like kind of, I don't know, like scratchy and like as if you're kind of, I think he puts it, dialing in from the Millennium Falcon or dialing into the Millennium Falcon, right? So pretty cool stuff. If you really, really want to impress your coworkers, this would probably be the way to do it. Forget all this Kubernetes stuff. Let's work on the virtual background. It seems to be the new hotness, right? So very cool. Thanks for putting that together, Ben. And then Steve, who's in our chat, we have an article from him on how we do GitOps at Metal. So check this article out from Steve. It's on Medium. Thanks so much for putting this together, Steve. I love reading more and more about how GitOps is being achieved. Like I'm usually like, due to a lot of my customers, kind of like on the edge where they're like, I want to use GitOps. I like the model, but they're just a little worried about the tooling maturity. They're worried about the DevOps flow change, the change that their developers are used to and all that jazz. So thanks for putting that together. It's always great to see, kind of these real world use cases. So shout out Steve, who's also in the chat. Great job. All right. Let's see who else we got going on here now. All right. Wow. Lots of chat. Very cool. Cool. Yeah. So be sure to check out tgik.io/notes if you haven't already. All these good links are in here as well. Okay. Cool. Tim, your coworker became a potato. I'm guessing you're referring to Slack backgrounds. Hopefully so, at least. All right. Let's get into some goodness about secrets. All right. So here's what I'm thinking for today. Whoever put the old episodes in the show notes, thank you so much. Be sure to check those out, 65 and 66. I am going to start with a bit of a review. I threw some, actually reused some diagrams we made before to kind of talk about how secrets work. And I think that'll just be a good primer for all of us. So if you haven't watched episode 65 or 66, don't worry. You're not going to be completely lost here by any means. But I'll talk about some of this stuff in review that if you want to deeper dive into, you should check out Duffy's episodes. As always, Duffy goes into great depth and it's super, super educational. So let's go ahead and start with the default secret model, okay? So default secret model. What does that mean inside of Kubernetes? Well, I've got a quick diagram that I'm just gonna bring up here. And sorry, the iPad's out of maintenance, so you won't get to see any of my kindergarten drawings today. But that being said, we have got, just trying to get my keyboard shortcuts here to work. Totally random, but today, right when I started my day, I have one of those. Actually, let me grab it. I'll show you. I have one of these like really nice control keyboards. I think a lot of you have seen them. They're neat because, and I know a lot of keyboard people do it now, but like they don't have, you can kind of clean it easily because there's no inset down there. So I woke up this morning, got on my computer to hop on a call, instantly smashed my coffee into the keyboard and just drenched this keyboard. So now it is pressing keys randomly throughout the day, which is a huge bummer, right? And Now I am using this keyboard instead, which is a very different experience. So if my typing is very bad today, you're going to know why. So just just bear with me on that. Hopefully the keyboard will dry out. I unplugged it right away. I probably plugged it back in a little too soon to test it, but I'll let it dry out a bit more. So yeah, it happens. Yeah, it is a downgrade, Duffy. You are not wrong, my friend. Anywho, all right, so secret behavior. Let's just talk about it at a high level, right? So Kubernetes has this API object that we're fairly familiar with that's called a secret, right? And whether you're explicitly using secrets today, I'd be willing to bet you that you are implicitly, at minimum, using secrets today, right? So I've got a kube cluster here. So if we just get nodes, this is a two node cluster running in my home lab, right? And if we do a kubectl get secrets, here's a secret. Does anyone know what the secret's coming from? Right, so it's coming from, I guess the name's right there, right? So it's coming from the service account. So when you establish a service account, in this case, there's a default service account in the default namespace, there's a token associated with that, right? And then that secret, becomes available to pods that use that service account. And those pods can use that secret to communicate with the API server. So that's kind of how Kubernetes implicitly runs secrets. But we know from experience that like when we run in Kubernetes, we want to be able to take secrets we care about in our application space and then move those over into a store somewhere that can hold database credentials, access tokens, all that good stuff, right? So that's something I'm sure we've all played with to some degree. Now, how do you do that, right? Well, there's this secret object in Kubernetes. So what we can do is we can take an example of a secret object, right? And we can apply that secret object to the Kube API server. And effectively, depending on how you set it, either you'll do the base64 encoding up front, or you could use this thing called string data, which will then base64 encode it when it goes into etcd, right? You're going to end up with base64 encoded string data in etcd, right? Now, Kubernetes gets a lot of slack for this notion, right? A lot of times, and I'm sure you could Google and find the blogs that are like, oh my gosh, why does Kubernetes think that base64 encoding is a security mechanism? Like that is atrocious, right? And it's not really that way. Like I don't think anyone who worked on Kubernetes is thinking like, hey, let's just base64 encode the data and no one will ever figure it out. In fact, if you saw the tweet for this episode, I tweeted, grab a drink, right, in base64, and all of you that I'm aware of that responded figured out what I was saying, right? So there's no hiding base64 encoding. It's encoding, right? It's not encryption, okay? So what do we do here? Now, the key thing to, again, really grok is that Kubernetes offers a separate API for secrets, and that's really the crux of this, because away from config maps, away from pods, away from all this stuff, we want separate RBAC in separate kind of settings that wrap these secret objects, right? We want to be able to put specific permissions in place. We maybe want how the verbs interact with secrets to be a little bit different than how the verbs might interact with a config map. So this is kind of like a base layer saying like, here's this API, here's these secret data things that you can inject. Figure out the safety by either extra configuration or integration with something else. And that's what we're going to be talking about today, okay? So when we get into this a little bit, again, default encryption, we're going to kind of lean into the notion of encryption at rest. But you know what might be helpful real quick? Let's just create a super simple object here, and then we can kind of build on this to make sure we're all grokking it. And again, I'm just going to glaze over it fairly quickly. Duff goes into this stuff in detail in his episode, so be sure to check that out. So all I'm going to do here, excuse me, I'm going to grab a secret from the good old interwebs. Give me just a second, okay? Actually, I'll grab one of those string data ones. So, okay, so we'll do vim secret. Actually, let's get into the TGIK folder just so I don't lose this stuff. So I'm in TGIK episode 113. Okay, that's the way I can commit all this in case you all want to play around with it yourself, right? So we'll do vim secret example, right? And then we'll do .yaml. Okay, great. So here's the deal. This is a secret object, secret API. No big deal. Just like our diagram. Where is that diagram? Just like our diagram, we're going to save this, and it will base64 encode it for us, right? Now, I use this thing called string data, and this is basically a way for me to put in the raw text, and then just basically when it gets stored in etcd, it will be base64 encoded. The string data will still show up in like the, the annotation that tells you what you applied. So again, not that base64 encoding is a security mechanism, but just be aware that that will show up in like true unencoded plain text. So let's save this up. Let's do a quick apply, right? So we apply secret example.yaml. Now, here's the deal. I got secret, my secret in the cluster, right? And as you could probably guess, if I kubectl get secrets, let's make sure I did it in default, right? Yep, okay, cool. Get secrets, my secret, okay? I can print out the secret. Now, this does not necessarily mean that the secret's not encrypted. It is not encrypted because I haven't set that up yet, but it doesn't mean it's not encrypted. What this means is my user has the RBAC to go and get the secret, right? So I can keep this experience of injecting secrets into pods, getting secrets in the command line, and so on, as long as I have RBAC. So that's not so much a problem. That's more of an RBAC concern. What is a problem for us, though, is, of course, how the secret is stored inside of our buddy, etcd, right? So how is that secret living inside of etcd? Well, let's go ahead and check it out. So I know in this case, if I do a get nodes o wide, we will have master 0, and here's the IP address. So I'm just going to SSH into master 0 real quick. All right, and I'm going to interact with etcd on the host. Now, Duff, again, I'm glad you're in the chat, Duff. Duffy actually has a really cool, like little, I can't remember if it's a script or just a YAML file for a pod, where you can hop onto a node. Again, this would only be for testing purposes, and interact with etcd directly from a container. So maybe if you got that link around, Duff, you could send it in chat. It's really cool. But I'm just going to kind of do it manually here with a shell script. Okay, so here we go. I will go ahead and call this etcdc, I guess, shell. Okay, and then we'll go ahead and just make sure it's executable once we're done. So chmod plus x for the etcdc, etcdc.shell. Okay, cool, great. All right, let's paste this in real quick here. Oops, caps lock. Oh no, I'm on a different keyboard, it's killing me. Okay, so this is a little script that I'm running. Basically, I'm assuming that I'm on the master node. Oh wow, do you all see those little glitches in my screen? That's weird. Hang on one second. I think it's my compositor. grep ipcom. Hopefully this doesn't blow anything up. If I disconnect, I will be back, but I don't think I will. Sorry, I did pkill there. Yay! Okay, y'all can still hear me, right? Hopefully so. That should have killed the weird artifacts that were coming in. Okay. So etcdctl, which will run on the host, and then we'll call etcd. Now it needs to know where what certs to use for etcd. So since I'm using kubeadmin, I know where these certs are. So again, this is just a little helper script so that I can execute commands with etcd and again, figure out where there are secrets and things like that. Okay. So now the only thing that I do need to go ahead and get to test this out is etcdctl. So again, many of you have probably used this before if you've played around with Kubernetes. etcdctl is a command line tool that will let you interact with etcd itself. Okay, so now we've just got to go out and get etcdctl. Let's see if there's a easy download link anywhere in here, or if I got to get it from the whole etcd releases page. Let's see, etcd. CD. Okay. There's probably a direct download somewhere, and I'm just not seeing it. But let's go ahead and grab the whole etcd tar. I don't think it should take too long. So we've got AMD 64. All right, cool. So let's go ahead and bring that down. All right, while we're downloading, let's check it out here. What do we got going on? Cool. All right. Looks like the conversation about mechanical keyboards is alive and well. Yeah, you get so used to your keyboard, right? You get really attached to it. I'm already pretty sad. What's funny too is I just put brown switches in it too. So that's a bummer. Just spent like a couple hours putting brown switches in. Thank you. Okay, cool. etcd. Okay, cool. Duffy put his etcd client in there too, so you should definitely check that out. Okay, cool. All right, everyone. So let me go ahead and unzip this real quick. So I will unzip the etcd tarball. Oops. Got to use the right commands here. So, oops, vf etcd. There we go. Okay. So there's etcd-ctl. Okay, where are you, etcd-ctl? You're inside of, oh geez, cd, etcd. At this point, I may have been better off using Duffy's pod. Okay, there's etcd-ctl. So etcd, okay, perfect. etcd-ctl, lovely. All right, let's get this thing in my path and then we'll move on. So etcd-ctl. All right, user local bin and sudo. All right, so again, just so you have the context, I'm on the host of my master node right now, right? So if we just do a quick etcd-ctl, make sure it works, looks good. All right, now let's see if we can make our little wrapper script work as well. So we called it etcdc.shell, okay? And then what I will do here, just to kind of bring this up, is run a quick command with it to get a specific key. So what is the key that we used? We'll do the default namespace real quick. So this will be etcd-ctl, paste this in here, hit enter. What did I do wrong? Permission denied, client key. Oh no, my API server client key, it's not happy about that. Maybe it's a sudo thing because it probably needs to open it up and it's probably protected. There we go. Okay, so what did I call that? What did I call that secret again? Does anyone remember? It was D. It was TGIK episodes 113. Okay, let's see what we got here. So I called that secret example YAML. We called this one my secret. Okay, so let's see if we can get to this path. Secrets. My secret. Okay, nothing came back. Secret, my secrets. It's been a little while since I've used etcd-ctl. I'm trying to remember what the command is again. So if is it list? etcd, here, let's get rid of this. So we've got etcd-ctl help. Okay, I'll make this a little bit smaller. Sorry for everyone's eyes. It should be under get. Okay, so I've got list. Oh, you know what? I wonder if am I setting the right API version for etcd-ctl? Let's see here. etcd-c. Yep, I'm putting in etcd3. Cool. Get from keys, grep my secret. Oh, good call, Duff. Let me try that. Oh, it's my dash secret, is it? That might be what it was. What did I put in? Oops. Get. Nope. Okay, let's see if your command there works stuff. Get keys from secrets. Okay, so we'll do this. Okay, etcd c.shell. Okay, what did I screw up here? Huh. My secret. Yeah. Where is the it's been so long since I've used etcd-ctl. What is the list command? Is there not a list command? Is it just get? I think that might be the case. So what do I have here? So I've got did I not have the namespace before? So it should be registry secrets default, right? My secret. Okay, etcd get. Nope. Huh. I wonder what the heck I've got going on with this little script. I usually use this guy to troubleshoot. Let's see, no list in v3. Okay, no list command in v3. Let's see if your recommendation works there. Yeah, no. Huh, super weird. I don't know what's going on with it. So let's just double check in the cluster real quick. Kubectl get secret. Okay, so I've got a secret in Kubernetes called my secret. All right, which seems to be okay, right? So I'm inside of the master node and I am authenticating okay. So if I just get, it should be under registry, right? Huh. Let's see. Yeah, there's no dash stuff. Well, there wasn't a dash in one of them I tried. So I would think that this would work fine, right? etcdctl. There it is. Okay. Who knows what millions of things I might have been doing wrong there. But we got it. Good job, everyone. Good job, chat. So here it is. This is the point we're trying to make, right? Is that it's not so much the fact that I can get the secret back in kubectl. It's the fact that if I went on the node, right, and I just basically looked into etcd, in theory, I could find this type of data, right? So this is all stored inside in here in plain text. Now, what does this mean for us here? So the question really becomes, what should we do about storing the secret data, right? Now, in our case, we're especially vulnerable, I'd argue, because not only is the obviously secret in plain text, but I'm in a co-hosted environment for my control plane, which means my API server and etcd are sitting kind of on top of each other. So the notion being, since they're running on the same host, is if someone breaks in to get access to the API server, etcd's sitting there as well. There's not like a hypervisor isolating them or anything like that. So I'm in a bit of a rough spot. Now, here's where we're just going to quickly kind of glaze over some of the other options. And again, this will be just a high-level review. Now we have two paths that we can go down. And one of them is encryption at rest. Another one is also encryption at rest, but it uses this notion of envelope encryption, right? So let's talk a little bit about these two. And again, I'm gonna quickly show a diagram here, which you all can hop into those other episodes too if you want to check them out in greater depth. Let me just quickly grab this one from my diagrams folder here. This one is secrets. Secrets, where are you, secrets? Okay, so I think actually I might have called this one encryption at rest. Nope, give me just a sec. I know you can't see my screen just yet. I'm just trying to pull up a file super quick here. What is this one called? This one is called secret-encryption at rest. Okay, let me pull that one in. Secret-encryption at rest. There it is. All right, great. Okay, so here's a model that we could theoretically go forward with. Okay, and this is what we would just call encryption at rest inside of Kubernetes. Now, in the episode that Duff did, you all might have seen him set this up. And basically what he did, I'm pretty sure my memory serves correctly that he set it up, is basically he went in and set up what we'd call an encryption key inside of the API server itself. And I'm just going to pull up a quick snippet from the docs so you all can see this as well. Encryption at rest Kubernetes. So if you haven't checked it out, you might find this page to be pretty darn helpful. Okay, so basically what we did in a previous TGIK is we set up this encryption configuration manifest. Now, this thing is a static file that you'd put on the host. Okay, so the idea is you would provide some keys to encrypt and decrypt, right? So in this case, you might just have one key. You can see that there's a couple different key types as well, all right? Identity is, this blank identity one is a default one that you're gonna want there for things that aren't encrypted. But effectively, when you put one of these keys in place and store it on the API server's file system, you update the API server manifest and tell it, hey, I have an encryption configuration for you, API server. Go ahead and load it, right? So then the API server can load this encryption configuration and start encrypting and decrypting these secrets. So basically what you do is you go in and you make one of these files and you can choose which option that you want here. There's a little bit of contention around what the right option is. Some people feel like the main recommendation is a little bit more vulnerable than others. A lot of people really like this thing called Secret Box, but in the encryption community, as I understand it, at least it's a little bit less mature. Although I think it's been around for many, many years. So if you do go down this path, definitely, like, if you're not a security expert like me, I would go to my security team and be like, here's my encryption mechanisms. What do I need to think about as far as choosing one of these different approaches to encrypting, right? So basically, you choose one of these and you make a key. And then your data, as it goes into etcd, is going to be encrypted going forward, right? So looking up inside of etcd here, I would just see a bunch of encrypted data, right? And again, I didn't want to just rehash everything that Duff did, so I just took a snippet before we did this session on what that encryption data would look like. So if I were to encrypt this right now and add one of these keys in, the exact same little piece of secret data that you see there would actually look like this if I did that etcd query, right? So as you can tell with this data, it had gone into the API server, it went through the encryption key to encrypt it, and then it persisted into etcd inside of this mode, okay? So, pretty cool. I mean, if you think about it, that does take us forward a little bit, right? We're a little better off because now if that person gets access to etcd, if they look into etcd, they should only see garbled text like this, right? But if you think about it, everyone in chat, if you kind of look at this diagram here, what problems might this, I don't want to say introduce, but what problems might still exist in this model, right? Because you might think, well, okay, just put an encryption key in, like everything will be fine. But think about like my host right now. Think about my host that has the API server and etcd running on the same node. What are some of the key things that are problematic here, right? So Waleed, you said, so is the key in clear text in static manifest for the API server? Yeah, pretty much, Waleed. You've hit it on the head there, right? So this key that I would be putting in place, right, from the encryption example, yeah, it's going to be sitting in plain text on the API server, right? And I guess that kind of answers your question, Maddie, as well, right? Like these keys, maybe you hold them in a repo somewhere, but at the end of the day, you end up putting them in this encryption configuration on the host with the API server, right? So think about this. I, as an attacker, go in and I get onto the node with your API server. Well, in a co-hosted deployment model, which many of us do run co-hosted control planes if we're not using like EKS or something like that, the encryption key is sitting right there on the same host, right? The same host that etcd is running on, right? So, we have a little bit of a concern there, right? We have to kind of think about the fact that I could just grab that key, go in and decrypt and all that kind of stuff. I also have to worry about people getting access to that key because it's kind of like I put a lot of my eggs in one basket there. My keys now live, my private keys live on the API server. It's something to think about, right? Another big thing too that might not be super obvious is now you own this kind of static process, right? That you're going to have to do key rotation with. You're also going to have to make sure, I mean, those of you who run a control plane, I'm guessing you run more than one control plane node, right? Unless you're just YOLOing your Kubernetes clusters or you're doing some weird like edge use case. You're probably running a multi-master cluster. So now I have to take this config, make sure it's on every single master and consistent, and I need to rotate these keys over time. Now, the rotation is kind of cool with this. Again, if you want to dig deeper, look into our other episodes. But the idea with these is that you basically, these are in order is the way to put it. So basically the idea is when you need to bring a new encryption key in to encrypt all new data, you'd add it to this list. And that encryption key would be the new encryption key used to encrypt all data. Now, one thing to know, like say you had an encryption key be compromised, all your existing secrets aren't just automatically going to be re-encrypted, right? The old encryption key would usually stay around in this model, at least for some amount of time, so that those secrets could still be decrypted as they need to. Now, if you were to change the secrets over time, persist new data there, all that good stuff, they will get encrypted with the new encryption key, right? But all those words, right? That's a lot of kind of overhead to think about. Rotating your secret keys. How do you kind of, do all these different bits and make sure they're coordinated on all the API servers and all that good stuff, okay? So you got to think about those bits. Now, You might be saying then, well, Josh, this doesn't sound very good. And that's not necessarily true. This is better, right? The key thing with these security discussions, at least the way I think about it, is you start here, which is base64 encoded data, right? And then you try to at least do as many things as you can to make it better. So if this is your only option, this is better than not having it, obviously, right? But there are some other options that are super, super cool. Now, that's encryption at rest in a nutshell. You put the key statically on the file system. The API server picks it up and encrypts everything going into the etcd. What about KMS envelope encryption? Now, this one, I really, really like the idea of it. I would be super interested, those of you in chat, if any of you are using envelope encryption, the KMS plugin system in Cube, please shout it out in chat. I'm looking for data here because aside from people who run in like GKE or run in Azure, I don't usually see this being used, primarily because some of the plugins are a bit immature, but I love the notion of this. So let's talk about that real quick, okay? So if we go back to this encrypting secret data one more time, we've got all the providers, right? This is all the static stuff. And then we've got somewhere in here, I don't know if it's in this, maybe it's on the same page. Let's do Kubernetes envelope encryption KMS plugin. Hopefully that's descriptive enough. That's what I'm looking for. Okay, so this is a cool model because it's going to use a key management service, a KMS, to go out and do some fancy stuff with encryption. So a KMS plugin provider could be Vault, it could be Azure, it could be GKE. A lot of the cloud providers, I think, really have the competitive advantage here because they already have like true KMSs running in their clouds, right? But let's look at a visual here because KMS is like, for me, my mind just kind of like melts when I think about envelope encryption without a picture because I'm a very visual person. So let's look at this, everyone, and let me know if this helps make any sense. So let me just once again open up a new diagram here for y'all, and this will be secret dash envelope encryption, I believe. Secret, there it is. Okay, our diagram's about to get a lot more detailed. So this is a diagram that I did that replicates, to the best of my knowledge, or represents to the best of my knowledge, the standard KMS flow for envelope encryption. So pretty cool. So here's the idea here. You don't have to be an encryption expert to grok this. And if anyone at chat wants to add some clarity to what I say here, please feel free, because sometimes I'm not the clearest. Secret comes in, right? Now, don't worry about too much about the word generate, but assume somehow a data encryption key, or you'll see it if you look in docs, it's called a DEK, D-E-K, will get created, okay? Now, here's kind of the brilliance here, right? You make this encryption key that encrypts this secret. So now, and we're still all, by the way, we're kind of like in the API server right now. That there's some technical inaccuracies with this, but like, for illustration's sake, bear with me, right? So now we're inside of the encrypt data with key. So we go in and we encrypt this secret, right? And then what ends up happening is we use KMS to encrypt our data encryption key with a key encryption key, or a KEK. So what's neat about this is, in the end, we get to store the secret and its encryption key side by side. So you might wonder, if you're first kind of grokking this, like, what do you mean we store the secret and its encryption key side by side? How does that make any sense whatsoever, right? You got to remember, this encryption key started gray, and now it's encrypted, this blue one here, right? So the idea is, if you got into etcd and got the secret out and its encryption key, neat, your encryption key is encrypted, right? So now you're in a place where you can't necessarily decrypt it. So you might wonder, okay, well then how the heck do you actually decrypt it? So when someone needs to come in and access the secret in the future, how do they do it? Well, again, that's the beautiful thing about it. This key encryption key, this KEK, can actually decrypt the data encryption key. So the notion here is we can delegate that. I like to think of them like master keys in a way, because they're the key encryption keys that are decrypting the data encryption keys. again, some people might give me some slack for calling it the master keys, but like what will then happen is we can go out when we need stuff and we can decrypt and just send to the KMS provider just the encryption key, right? Because ideally we don't want to send our secret over the wire. We just want to send the encryption key over the wire. The KE key can then go and at some layer, the KE key can then unencrypt the DE key. And now we can access our secret the way that we're expecting. And the beauty of this is now you've got this centralized key management service where you can do your rotation. You have all these fancy kind of RBAC and privilege settings that you can do. You've kind of decoupled that full encryption concern from Kubernetes. And you've got this really neat model where you can just, again, store your secrets right next to their encryption key. And should you need them, the KMS service, key management service provider is just there to decrypt data encryption keys should you need them, right? So that is a pretty neat flow. Now, the warning I'll give you about DEX and, the warning I'll give you about KMS is I really like it, but it's something that's probably more relevant to you if you're using a cloud provider. I love the model. I love the storing the data encryption key with the secret. It keeps things fairly simple. It moves the primary keys that you need to really, really protect outside of Kubernetes, which is a huge pro for me, right? I don't want to put too many eggs in that Kubernetes basket. And then I can use services that are well established like Azure, Google's key service stuff and Amazon's key service stuff and so on. Now, the thing I'll just warn you about before you get too excited about this, because I remember when I first read it, I was like, oh my gosh, this is so freaking awesome. Let's do it. Again, to my knowledge, Google's KMS provider is maybe the most mature, which is really cool. So if you're running on GKE, that could be neat for you. I believe Azure has one as well. I'm not as sure about Amazon. There was an effort to make a Vault one, Vault KMS provider. It was actually coming out of Oracle, but the project didn't gain wings for reasons that I don't really know. I don't know if anyone in chat knows, but it seems like the project got archived. So it would be really cool to maybe use this KMS model with something like Vault. But as we're going to talk about just now as we transition out of the review, there's a lot of other really cool ways to integrate with external systems as well. So we'll talk a bit about that. Cool. Let's see what we got going on in chat. Cool. Yep, it looks like a lot of you gave a lot of good reasons why that standard encryption at rest methodology probably had some big risks associated with it, right? Yeah, cool. Yeah, as Duff said, the KMS is rad, but you're probably only going to use it with a cloud provider unless someone has updated a Vault version of it, which I have not seen, but I'd love to see that eventually. Cool. Yeah, and then at the very end there, AKS doesn't implement envelope encryption for Kate's native secrets. Interesting. They're using the FlexVol driver or the CSI driver. So we're actually going to talk about that eventually too, for what it's worth. There's a new approach to a newer approach to doing secrets via the container storage interface plugins. So we'll talk a little bit about that as well. So pretty darn cool stuff. Yeah, so, and I know some of you are asking about the graphics. I'll be sure to include some of these graphics as well in the maybe not the show notes, maybe in the GitHub repo. Are these graphics helpful for you all to kind of understand the flow of all the stuff that's happening here? My brain, like when someone talks to me about envelope encryption, I just can't grok it until I see a picture like this. So I figured I'd bring it up and talk a little bit about it. Okay, so I think we're done with review now. And I know we are already about an hour deep, so we'll probably go for at least another 30 or so minutes. So if you've got time and a drink and want to keep hanging out, feel free to do that. That would be really cool. So now we're going to talk a little bit about some of the options for today. Some of the things that and this is a very selfish thing, but I talk to customers about because they usually ask me about them. One quick mention that I want to make is just the notion of an external provider. So here's one thing, and this might come across as an unpopular opinion. I'm not trying to be controversial, genuinely, but one of the things that I'm not super crazy about with Kubernetes is trying to make Kubernetes be a true enterprise grade secret store. Okay. So what I'm getting at here is like, again, I know I just talked up this envelope encryption methodology. It's great. I like it a lot. At the same time, there's another part of me that's just like, wow, when it comes to it at these large enterprises, they want like HSM support behind the scenes for their secret stuff. They want all these things, or maybe they've already got secret management systems. And I really like the notion of, aside from the things you have to store in Kubernetes secrets, like maybe service account tokens and stuff, I love the notion of taking the secret concern, which is usually a pretty complex thing in a lot of enterprise environments, and just keeping it outside of Kubernetes altogether. I really, really love that model. An example being, I have had customers who run Vault, and they choose to not run it in Kubernetes because they already had it running in VMs and all this, and that's totally fine. Like, there's nothing that says the secret store needs to run in Kubernetes. There's nothing that says the secret store needs to be persisted in Kubernetes etcd. I really love the model of taking that out. So like maybe you run Vault in Kube, but it's again not persisting to etcd, which could be a really good model because Vault is so feature rich, right? Or maybe you run Vault in a VM or some other secret store and you integrate Kubernetes with it. I really love that model where you use an external provider rather than trying to retrofit etcd to use secrets, okay? Now, again, not trying to be controversial, I have customers that do encryption etcd all the time. It's okay. It's just about knowing your risks, right? So I'd be curious to get some perspectives from what you all think in chat, right? Like, what do you think about running an external provider versus persisting in etcd? I think there's a lot of trade-offs there to really talk about. And that very smoothly transitions us into our last set of topics here, which is really like, what are the options you have today? Okay, so there's three that I picked because I talked to customers about them a lot. One is I'm going to talk about Vault's injection model, which I think at the time that you recorded, Duffy, I know you covered Vault, but I think you were using the Kube Vault project, which is another one that we put a link into. You should check it out. Apps Code has done some really cool work to kind of create some neat secret management aspects built around Vault, to my understanding. But there's been a lot of work since that recording in having some more native integrations with Vault. So I just want to talk to you about those today. Then we're going to talk about sealed secrets. I was a little bit unsure whether to talk about this one. Sealed secrets is one that my customers ask me about a lot. Usually they're a little confused. They think that sealed secrets is trying to solve the same problem that something like Vault might solve, which is definitely not true. But sealed secrets is a really cool model and something interesting to think about. And then I want to end today with which someone was talking about in chat, the CSI secret driver, right? So we'll talk a little bit about where that's headed. I am sorry, spoiler alert, really, really excited about the CSI secret drivers. I think the model is really awesome. It follows some of the design ideas that I talked about liking, like having an external provider, having Kubernetes integrate with that. So we'll foreshadow that a bit. I don't know if I'll get a provider set up, but we'll get into it. So, all right, let's start off with Vault injection. Enough talking, Josh, okay? So let's, I'm going to open up another diagram for you all here, and I'll also try to check chat as I go through. Yeah, Duff, I miss the crayons too. I love these diagrams, but I kind of like drawing like I'm in kindergarten. It's really fun. Bogdan, you asked, does the API server still need credentials for the KMS though? Yeah, so there are some details in the provider about how it authenticates with the KMS. So this is why it's really applicable to a lot of cloud providers, because you can oftentimes use like some of their existing IAM settings so that the KMS approach can actually go in and what did I do here? Oh, I have a window open. That's why. So that the provider can go in and actually talk maybe through like IAM privileges that are available to it to the KMS providers. That's a good call out, Bogdan. You would definitely need access somehow to the KMS provider in the cloud. And then sorry, you totally just answered that. So thanks for throwing that in chat. I should have looked a little bit lower. Oh, cool. So Caleb, you're using Bonsai Cloud's Bank Vault mutating webhook. That's awesome. Yeah, so mutating webhooks are another really interesting one, right? Doing some amount of mutation on the front end as secrets go, and that's really cool. I got to check out the Bonsai stuff. Okay. And then the last comment in there too, I'm going to call you pianist because you're making really good comments, but I'm not going to say another crappy pianist because it's too long. Yeah, that's a great point. You can't ever like fully avoid Kubernetes secrets. They're so baked in, and they can be okay. They do a lot of really cool stuff. I by no means don't want to give off the impression that I would say, hey, never use Kubernetes secrets. But what I do talk to a lot of customers about is like, hey, you don't have to make Kubernetes do everything. Do you have an existing secret store provider you're used to? Are you interested in using one like Vault and so on? So there's just a lot of options, and I think a lot of trade-offs. Yeah, ACP is a good one too. Totally agree. Yeah, so it's such an interesting, deep conversation, right? You really got to weigh all those different trade-offs. Okay. Let's talk Vault. Sorry, I love this topic. I feel like I could go on for hours and hours. So let's pull up the diagram for what I'm going to get into with Vault. Now, some of you might know Vault is a project by HashiCorp. It is basically like a key value store that has a lot of really cool feature sets to ensure that you could store sensitive information inside of it. Okay. Now, I'm not a Vault expert. Don't claim to be a Vault expert, but I have integrated Vault a couple times with Kubernetes. Now, if you have Vault and it exists in your environment, that's cool. And in the past, there's been a couple ways that you could do integration with Vault. This is a pretty interesting topic, actually. So let me just talk about the two ways that you could do it, right? And when I talk to a lot of my customers, this is exactly the conversation I have with them, right? So you have a secret provider, okay? And the question is, on what, this keyboard's killing me. On what level do you want to integrate? Now, what does that mean here? So let's assume you have Vault or some other system out there. Where do you want the integration to happen? Now, there's two really common answers here. There's at the platform level, right? And then there's at the app level, okay? Now, I don't know how familiar you are with projects like Spring. Let me just see if I can find the right thing. Okay. So Spring is a framework that you use in Java. It does a lot of interesting stuff. One of the super interesting things that Spring does is it has ways to, in the case of Kubernetes, you can actually run things in Spring that will talk to the Kubernetes API server that will bring down things like configuration maps and secrets right to your application. So you just define it in your code and it integrates. Now, it's interesting here because you got to kind of weigh this. The one trade-off that you've got there is you've got, all right, well, you're doing this at the app level. Now all the apps need to be aware. Now all the apps need to have the appropriate RBAC to read their config maps and secrets, right? Because in theory, you could just mount volumes into the pod, right? We've always had volume mounting available to our pods. And then you could go in and just with Spring, say, hey, look for my config in this directory, done deal, right? Which I kind of like that approach a little bit more. I don't super like the idea of making my app aware of the platform it's running in, but what's the benefit there, right? Well, you have a lot of security because like you can handle this, you can scope the security concerns in the app level. You have a lot of customization because now you can program your app to talk to the API server or to Vault in its own special way. So this can be a viable model if you're willing to really take on that trade-off of making the app, in my opinion, a little too smart. And again, really binding the app to the system, right? Because the great thing about volumes is, I hope Kubernetes has a really long lifespan, but let's say it goes away in 10 years for some reason. Again, that's not going to happen, but let's assume maybe it did. Your app is looking into volumes, right? It doesn't know about the ecosystem it's running inside of. And I really like that notion when you can achieve it. So what I'm getting at here is you have to really weigh these two options. Do you want to integrate with your secret provider at a platform level or an app level? And I saw Duffy mentioned in chat, platform level can be one of the most convenient ways for the developers. Now, you're taking away, in my opinion, a good amount of their flexibility, perhaps, which could be a good thing depending on how you look at this. You're also putting a lot of onus on your shoulders. Now you're responsible for how the secrets get in their app. Congratulations, platform people. You're responsible for that now, right? Maybe not how it propagates into their classes and objects, but getting it into their app is now your responsibility. And for a lot of big organizations, they have a delineation between platform and apps teams where there's kind of this tug of war about who should own what. Now, I'm going to focus on the platform narrative here. I'm not going to pull up a bunch of Java code with Spring. Here is an interesting model that Vault offers inside of Kubernetes. And I happen to like this model. This predates, at least to the best of my knowledge, a little bit of the CSI secret driver work. So here's what happens. You create a pod, right? That pod goes to the API server, and you're going to be able to run this little guy called the Vault Agent Injector. So whoever mentioned that Bonsai mutating webhook, I don't know how close this is to that, but this is effectively a mutating webhook, okay? Now, what will happen, is when the pod gets created, this Vault Injector is going to inject an agent as an init container. So those of you who are familiar with init containers, they come first when the pod starts, right? The init container is going to fire off. It's going to go over to Vault and get your secret for you and store it in the file system, okay? Now, there's also some other conventions you can add too. Like you can tell via annotations that you also want to run the sidecar Vault agent, okay? And this one is basically, I think it's actually literally the same image as the init container, but this one is going to run over time so that if there are changes in Vault or rotations of secrets and all this kind of stuff, these Vault agent sidecar can bring that back into the pod. So that's kind of a key idea here, right? Think about this for a moment. We're not pulling our secrets from etcd, at least maybe our service account, but at least not like database credentials and stuff. We're going strictly to Vault, okay? We're delegating all of the pieces to Vault altogether. And through this model, we're not writing code in our application that integrates directly with Vault, right? Instead, these little agents are giving your developers, for those of you in the chat who are like more on the platform side, your customers, your developers, an experience where all of a sudden a volume shows up in their container and it's got their secret inside of it, right? Or I should say really a directory shows up with a secret in it. That's kind of a cool experience for them. And it's again, a little bit more complexity for you because now you got to manage the injector. Maybe you're also responsible for Vault, which in and of itself has a bunch of production concerns you got to think about. And then you're worried about making sure that all these pieces can communicate, right? So do y'all want to try this? What do you say we give it a shot real quick and see if we can set it up? Let's do it. There's too much delay in chat, so I'm just going to assume you're all excited to try it real quick. So let's see if we can do this. I've done this a while back for a customer, so I think I can pull on some previous knowledge. So let's hope I don't bring us into a rabbit hole of despair here, okay? So again, I have Cube. I have a 2-node cluster here, just so that you know. We will do a kubectl get pods. I have no pods running in the default namespace. So we're going to start off by installing Vault. Now, to save you the time of me searching this, I went ahead and grabbed the Helm chart off of the internet. So I have got the Vault Helm, and it's the 0.4.0, which is, for whatever reason, what the docs told me to use. All right, so here's what we're going to do. We're going to run a command. Let me actually bring up the docs here, too, so I can reference those for you all once we get in the show notes. There's a really cool page. Here it is. Yeah, but by the way, just to call this out, HashiCorp is crushing it with their Learn website. I don't know if you all have checked it out, but the tutorials are really awesome. They do a great job here. So whoever works on the Learn stuff at HashiCorp, great job. This is really, really cool. Okay, so I think there's a Helm install command. Helm. There's a couple things when you install Helm, actually. Let me just show you real quick to make sure we're all on the same page. There's a couple things that we care about. One of them, if you try this on your own, if you're watching this video later maybe and trying it, there's a dev flag that we want to set to true. By default, Vault will try to create a persistent volume claim. I don't have any of that stuff set up, so I'm going to do a very small, naive implementation with the dev setup. Okay, and then the other thing I need to do is make sure that the agent is turned on. That's that little injector I was telling you about. So I need to make sure that this little guy right here is enabled, so that mutating webhook is turned on. Right. So let's try this out. Okay. Where is there? I know they've got it somewhere in their docs. I saw a Helm command earlier. There it is. Okay. Server dev enabled is true. And then I also think, I don't know if the agent's turned on by default. I might want to double check that real quick. So let's go back to the values. And I don't know if everyone on this call is familiar, or on this session is familiar with Helm, but these are just variables that dictate how the thing deploys, right? So what is it called? I think it's just called agent. No, it's called injector. Oh, there it is, injector. Okay, injector. Okay, it is enabled by default. Great. So let's roll with this. So I'm going to just do their Helm install. I'll do it to my local directory just to make sure there's no variance there. I guess I didn't really need to bring that locally. Okay, great. And then let's do a kubectl get pods real quick. All right, I'll make this a bit smaller. All right, fingers crossed, everyone. Hopefully this starts. There we go. Hey, look at that. All right, killer. So we've got Vault 0 running, and we've got the Vault agent injector running. Now, again, keep in mind, these two pieces are very important. What you are looking at here is Vault. I have chosen to run it in the cluster for convenience sake. They even say in the Helm chart that there's a ton of stuff you need to think about for production, so don't just Helm deploy and expect it to be production ready. And I've also got, excuse me, need to drink more. I've also got the agent injector here. So those two pods are running. We're good to go. And if it put the injector in, it probably put in a, oh gosh, what's the resource name, everyone? Is it mutating webhook configuration? What's that API? Mutating webhook configuration. Hey, there it is. I think someday we should all have a pub quiz on the Kubernetes API and see who can remember the most API resource stuff. Okay, anyways, I won't get too deep into this, but this webhook configuration is basically saying, hey, API server, look for this type of operation on this type of resource, okay? And when that comes in, that tells the API server, go through the injector and put these little extra containers in its place, all right? All right, yeah. So I'm gonna drink a beer for that one for sure. Yeah, Duffy, you're on my team for the API pub quiz. So I'm sorry, but I already called that. Okay, so here we go. Yeah, everyone's on Duffy's team. I know, Duffy. This might become a one-team thing. Maybe we could all go against Duffy. That could be a good idea. Okay, so anyways, what do we got going on here? So we've got the injector, we've got the Vault agent. Now, I need to go into Vault and I need to add a secret and stuff like that. Let me just pull this up in their documentation again. Before I forget, let me just put the link to this inside of the show notes. So this will be Vault injector how to. So in case anyone wants to play around with this, or if you're watching this video, check out the show notes and it'll have the link in there. Okay, cool. So let's instantiate this. So we need to create a Vault secret. Okay. Now what I'm going to do here is I'm going to cheat by execing into the Vault pod. Okay. And I am going to do all the commands directly inside of the Vault pod. So right now I am in Vault. You can see Vault is the #1 process there. Or actually, no, it's not. The entry point is the dumb init. So it looks like they've got that running as kind of the init, and then Vault is PID6. Okay. So I am going to go ahead and create secrets, and I'm just going to pull these out from their documentation and explain them. Again, mostly just concerned about the integration with Kube here, not so much about the inner workings with Vault. So we go ahead and we make a new path inside of Vault, kind of like our namespace-ish construct in Vault. I might not be doing that justice, but this is like a category, a folder called internal, okay? So we've just made that exist. Now, we're going to roll with database credentials here. So Vault has another command that we can do called kvput. Again, think of Vault as very much like this key value store that has all these amazing things to integrate with underlying, not integrate, but to provide really secure key value store for sensitive information. So we're going to put something in internal, and we're going to call it database config, and it's going to have username and password. Okay. Now, I'm not a Vault expert, but I think if we do Vault KV, Vault KV, it's either read or get. I can never remember what their API is. Let's see if we can try this real quick. I'll drink if I get this verb right. Hey, there it is. Okay. So Vault inside of Kubernetes has a secret now, right? It has no relation to etcd at this current moment. Great. Now, what we now need to do is go in and set up Vault with Kubernetes authentication. Now, this is a whole topic in and of itself, so I'm sorry that I'm not going to do it justice here, okay? Good job, chat. You knew the verb right away. Good work. So here's what we're going to do. We're going to turn on this thing called Kubernetes authentication. I don't know, Duff, in your session, if you used kubeauth at all for that other project that you were using. I'm guessing you probably did. But basically the idea here is we're going to set this up so that Vault can use the token reviewer, or sorry, what is it? Token review request API. What's that API name? Duffy, here's your chance. What is it called again? Token access review. What is it? Where it can then go out to the API server, validate the service account, more or less, the identity. And then based on authorization rules we put in place, we can actually say who has access to what. Brad beat you, Duffy. Subject token access review. Good job, Brad. All right, so let's go ahead and set this up as well. So I am going to run another command, which basically writes the configuration to Vault. This is all in their documentation. All it's basically doing is writing the auth Kubernetes config. It's putting in the token reviewer, JWT, which is available at this path. This, I'm in the pod, remember, so this environment variable should resolve. This should be the service IP, I think, of my API server. Someone correct me if I'm wrong there. And then we've also got the CA cert so that we can trust it, right? Okay, now, let's go ahead and run that. So now we've got the config in place, okay? And then I'm also going to write policy, and this is basically going to be like the capabilities. So, again, speaking to the complexity, now we have this another layer, since we're running Vault, of potential policy where we need to define the capabilities of certain things. So the whole authentication story here is now more complex because we have this other system that we're kind of tying into Kubernetes. Now, I probably should mention Vault has a bunch of authentication mechanisms. You don't have to use Kubernetes per se, but that's just what I'm using here. And I'm really just making use of that access token review, right? So let's go ahead and run that. All right, and then some questions coming into chat. Yep, I think, Waleed, you answered that question perfectly. Duffy, see, that's what happens when you go AFK. You lose the pub quiz. To your points, Shams, the main thing about the operator is a lot more focused on lifecycle management of Vault in Kubernetes, right? I haven't looked at the operator recently. It had some sharp edges back when I worked at CoreOS, so I don't know. Is anyone running the operator in production? Is that still a pattern that folks use? It could make sense. I never followed along with how productionalized the Vault operator ended up getting. So just to be super clear, everyone listening here, I'm not using the Vault operator. I'm just installing Vault using Helm. And I would theoretically, if I were to continue with this, maybe use Helm to do the lifecycle updates and things like that. All right. Anyway, so now we've got the policy in place. We're all good. Let's go ahead and exit out of the pod. All right. Let's see if we can get this thing wired up. So again, here's what we're going for. We've got the API server. We've got the pods that it creates. And we've got Vault here as well. So my hope is if I send a container through, the injector will be like, oh, I care about you, container. You want secrets, right? Here's some containers. Go ahead and talk to Vault using your service account token. And then Vault will do some magic to figure out whether you should be authorized and all that jazz. And Vault even gives you like another token with a TTL associated with it. It's a whole thing. But nonetheless, that's kind of the flow we're going with here. So inside of their documentation, they have a sample app, which I've just grabbed as well. This sample app is basically going to let us mount a secret. So that's what I'm hoping to test with you all, that we can mount a secret effectively. So let's do this thing. If we go into, Josh, where did you put that actually? I think it's one directory back. Vault Guides, I think. Vault Guides. Oh, they put all of their guides together in one repo, don't they? Okay, give me just a second. I'm going to find the right directory so I don't screw this up royally. That's good. That's good. Oh, I found it. We're good. Vault Agent Sidecar. Cool. All right, yeah. So again, if you go into the notes, if you try this yourself, this repo is in their Learn page, so you can check it out. Okay, let's do this thing. So we've got Kubernetes, we've got Vault set up to integrate with Kubernetes for at least just authentication of that user. Let's go ahead and look at the service account. So one of the first things we're going to want to do is we're going to want to look into example. What do I have here? Service account internal example. Okay. So first things first, we're going to create a service account. That service account is going to be tied to the deployment because remember, Vault and the way we've currently got it set up is going to be able to pair service account and the tokens to figure out whether you should have access, right, to that thing. So let's do this. Let's go ahead and apply that file. So we'll do a quick kubectl apply. All right, good deal. We've created the service account. Now, let's go ahead and make an application. Now, it looks like in their docs, let me bring this up here. Oh, actually, sorry, I've got it here. So if we do a deployment one org chart. Okay, here's a deployment, just so we all know what's going on here, right? I have no idea what this deployment does, by the way. We're not going to figure out how to make the UI work and stuff like that. But it is a deployment, which the goal here is, again, who cares what the deployment is? We just want to mount the secrets that it needs and should care about, okay? So the first thing we're going to do is just deploy it as is. There's no real instructions for Vault to go in and actually to do it, for the injector more or less to actually do anything with this. So if we do deployment o1 org chart YAML, okay, great. Let's see if we can get this pod. So kubectl get pod, right? All right, great. So org chart is running. Org chart does not have any secrets in it. I'm going to do a modified version of the instructions to show you all here. If I exec into org chart and then get into their bin sh, okay, so now I'm in the org chart pod, right? I do not have any active secrets, if you will, inside of, it looks like it's going to eventually have us put this in vault/secrets. This directory probably doesn't exist, right? Now, can we inject things into here? That's the question. So remember, there's a webhook admission controller. Why didn't, if you look at this, why didn't the Vault injector pick up and do something with the secret? Well, it didn't have any instructions on what secret do you want, what settings do you want for like refreshing the secret? None of that stuff was there, right? So one of the models that they use, and a lot of people who set up their own webhook controllers oftentimes evaluate annotations to determine behavior. They're going to have us put annotations into the deployment to effectively make that happen. So if we go into, I'll exit out of this pod, and we go into deployment 02. Oh, it's a patch file. I don't really love patches. We'll try it out anyways. Basically, this is going to add 3 annotations to our existing deployment. First annotation it's going to add, agent inject true. So this is going to be like, hey, go ahead and put the agent in, grab the secret and put it in. It's going to tell us what the role is that it's using. Again, you might have remembered the role from when we set up Vault. And then it's going to tell us effectively what particular config we want to grab, right? So with this annotation in place, we should be able to go in and put this in. So let's do it. So we will, let's see if they have a patch command. I always screw up patches. They freak me out. So I wonder if they have a example patch in here at all. Let me pull over the instructions for you all to see. Patch. Inject, that's good. Annotation, there's a patch command. Oh, that's funky. Weird. Do you need a cat like that if you do a patch? Is that a thing? Can you not just point to a file? I guess I haven't done a patch in a long time. Anyways, okay, so patch. Oh, I guess this would be patch kind of like, yeah, okay, I see what they're doing. Sorry, that was a silly comment. Okay, go ahead. I think you still could point to a file though. I don't know if the cat thing's required. Anyways, so let's do kubectl get pods. All right, we're knitting again right here. Now, let's see what we've got going on here. If I do a get pod for this pod O wide, oh geez, not O wide, but O YAML. Okay, let's look at this pod real quick. Container not ready. I'm looking for an init container here, everyone. Okay, so you can see the volume mounts are here now, right? So the intended volume mount. Yeah, I know I need to embrace customize, Steve. It's a long journey for me. I'm getting there. Where is my init container friend? There's my init container. Okay, great. So here's the init container, right? And it is doing some stuff to make it be able to communicate with Vault. Now, it's interesting about the init container. I remember this now that we're looking at it again. They shipped the whole Vault. They used the whole like Vault image for the init container. I guess it just seems like you don't need the whole image. I think the Vault image is like hundreds of megabytes or something. It seems like you wouldn't need that just for the client aspect of Vault. But maybe that's just a convenience thing. Anywho, the key thing that I'm more so trying to get at here is we all of a sudden have this init container, and this init container was sourced from the mutating webhook, right? That's the key thing to keep in mind. Okay. Now, please tell me you started. No. Okay, what's wrong with you? So it's still initting. Let's see if we can troubleshoot this real quick. So we'll get pod. Okay, we will paste that in. Okay, let's get the, what do you think? Should we get the logs, I guess? Let's get the logs for the init container here. Vault agent init. Let's see here. Okay, see. Interesting. Error making API request. Okay. Invalid role name, internal app. Huh. That is quite interesting. It makes me think that I missed something in Vault. Yeah, interesting. Now, when you say I'm not authenticated, Duffy, I'm thinking that I'm failing to resolve the role name at the Vault level. Are you thinking that I'm failing authentication to the Kube API server from Vault? Did I not apply the service account? I did, right? I think let's see here. Okay, well, so quick sanity check, right? kubectl get service account. Okay, sanity check here, everyone. We've got internal app in place, right? That looks good. Yeah, I agree, Duff. I think it's at Vault itself. I got it. I think I must have done something wrong configuring. I bet we can figure this out. Okay, service account's there. In their deployment, let's just make sure that there's no chance that their thing is wrong, which would suck because I just talked up how awesome this is. Okay, that's good. So we got the right service account pairing here. It seems like I didn't configure Vault right. Let's see if we can figure this out real quick. So I'll exec back into Vault. Okay. All right, I'm back. Wait, I should double check that. Am I in Vault? Exec. Yeah, okay, I'm back in Vault. What do you all think this is? So I went through and, okay, we know the secret exists in Vault, right? Because we did a Vault KV get. Oh, you mean oh, Steve, I see. I think I'd be surprised if the service account in Vault wasn't already set up to work with this, but you might be right. I'll double check that in a second. Good point. Let's go ahead and do a Vault KV get, right? Okay, let's do a get against internal database. Is this where the file was? Internal database config. Oh, wait, check that out. Create a path for secret web app config. And this says internal database config. Are my eyes deceiving me here? Does that make sense? Internal database config. Let's make sure that one's there first. Internal database config. Okay, secret's there. Okay, we've got Kubernetes authentication enabled. I think that's a true statement, right? Okay, path is already used at Kubernetes. Fair enough. We wrote the authentication config stuff, which should be this. Okay, data written. I think I wrote this out. And actually, let's double check here, everyone, because I just want to make sure. I swear this should resolve to the service IP, right? Okay, that resolves to the service IP. Let's just make sure the token's there. I gotta imagine it is. Token, okay, I think we're good. Actually, you know what you can also do here? I'm remembering some Vault stuff as we go. You can also, what is it called? What is that command I just did? There it is. You can also read this, I'm pretty sure. Okay, good. Issuer, NA, Kubernetes CA cert. That is good. That is good. Okay, so we've got that. What else do we got going on? So I think I did this. I probably should double check, right? Because this is as I understand it, this is the mapping to give me the capability, right? So this policy write for the path internal data database config. Internal data database config. Let's make sure this is right. Internal database config. Huh. If anyone's really good with Vault, does it make sense that data is here? Is that just a standard convention that goes inside of this internal piece? Because that does look different, doesn't it? I wonder. That looks very strange. I guess it can't hurt to open it up even more, right? So let's just do that real quick. The next step I didn't do. What next step did I not do here? Cube. Okay, where we got this? So we've got that. Okay, we've got the secret. Sorry, I think I scrolled up too much. So this. Oh, did I not do this? It's funny how easy it is to skip a step. I'm pretty sure I didn't do that, right? Is that what you all are talking about in chat right now? I don't remember doing that. Is that what y'all are thinking in chat, this guy? I think that might be it. It is super interesting that path was slightly different though, isn't it? Maybe data is just like a standard convention. I don't know. Okay, let's try it. So we'll exit out. Oh boy, look what we got. That looks pretty promising, doesn't it? Woo, good job, everyone. Thank you, chat, for actually following the instructions, unlike somebody. So we'll go inside of this one, which I think is slightly different. And if we have a secret, I think we did the thing. Okay. So what was it again, everyone? It was secrets. Oh boy, no, it was Vault, right? Vault secrets. Hey, check it out. Awesome. Very cool. All right, so we have the injection working, which is really neat. Good job, everyone. That is worth cheersing to. All right. So there's a bunch of other stuff with Vault that I won't get into, but I'll just high level it real quick because I want to make sure I can do a little bit of justice to sealed secrets and a little bit of justice to CSI drivers before I say goodbye to you all. So that's really exciting. I'm glad we got that working. Okay. Now, there's a couple things that are probably key to mention. Let me start with my diagram, actually. I had this conversation with a customer recently. That's only the reason why it's so fresh. There is another annotation that you can put in place if someone in chat wants to paste it, if you know it. It's something like secret update true or enable or something. But basically the idea is I deployed today with the init Vault agent in my app container. If I add that extra annotation in, it will also include a sidecar container, which is another Vault agent. So the idea is the init container happens to make sure the secret's there before the app starts. But then if you put that other annotation in place, it will actually sit there and it will kind of go and talk to Vault. And over time, if you change a secret or something, it will actually go in and change that secret. So look for that annotation. It's pretty cool. Another thing I just want to give a shout out to Vault. I won't do it right now, but as you probably noticed, it kind of outputs Vault data in like, it almost looks like it's like thumped print effing map in Golang, right? For those of you who write Golang, this probably looks pretty familiar. So there's a whole templating system that you can use in here. A lot of these secret approaches support this, but just look for, let me see if I can find a quick snippet. Templates, there it is. So you can do stuff like this, where effectively you can put in templates that kind of look like, if any of you have done Go templating before, kind of look like Go templating so that when the app gets its secret, it's in a format that it's comfortable consuming or knows how to consume. So again, like kind of like we were talking about Zookeeper earlier, right? Like the idea would be maybe you could move apps to Kubernetes and like everything about how they consume secrets would not have to change at all because you can do these really cool, clever things to make it work, right? So there's, again, an annotation somewhere for that. Sweet. Oh, data is a standard for V2 stores. Okay, good to know, Caleb. Thank you. Cool. Okay. So I know you've used up a lot of time, but if you've got about 5 more minutes, let's just quickly talk about 2 more topics real quick that I think are really interesting. I won't implement these ones because we've been together for a while now. I want to give you all your weekend, but not that you're forced to stay here, of course, but I want to end this on a bit of a good note. So let's just talk about sealed secrets real quick, and then let's talk about the CSI secret driver. And this will be a really good kind of like cliffhanger for those of you who are interested in it. And if you ever want us to double click on it, maybe we could do a TGIK on one of these as well. So Vault sealed secrets. Quick and dirty with, sorry, not Vault sealed secrets, sealed secrets, which comes from a company called Bitnami, formerly, now VMware. So they're actually part of our family. I promise this is not a biased look at all at secret things, but I get asked about sealed secrets all the time. People say, hey, do I need to use Vault? Could I just use like sealed secrets or something like that? So sealed secrets is a really cool model. And I hope I do it justice because I haven't necessarily used it in production yet, but I have used it in development environments with my customers. The way that I think about sealed secrets is it's not solving the same problem, right? The idea of sealing a secret is that you could even store the secret in something like your Git repository, fully encrypted. And while people all over the world can see the secret, it's in an encrypted format. And the notion with sealed secrets is that something runs in the cluster that can decrypt the secrets should they need to be decrypted, right? But it isn't a replacement for actual encryption in etcd. And here is why. Here's a quick flow to kind of show you a little bit of what I'm getting at here, okay? So let's look at sealed secret diagram. So file, open, I'll move this on over to diagrams. Let's see, where's my sealed secret friend? So secret, sealed secret. Okay, do I want to show you all the behavior one? Let me just check that real quick. Yeah, I think... Hold on, I'm debating between 2 different images. I think I like this one better. Okay, I'll just pick one and then I can always show the other one too. I have 2 graphics for this one. All right, so here's the deal with sealed secrets. When you deploy sealed secrets, it basically runs a controller inside of the cluster. Now, what's cool about this controller is it has the private key that it can either generate, or I think you can maybe provide it a private key, I'm not sure, but it can at minimum generate a private key and it can rotate that key over time. What happens is your users use this little utility called kubectl fetch cert, and it actually goes out to the sealed secret controller and gives you a public key back. Okay, not the private key, but the public key. So what is public and private keys in asymmetric encryption, right? The notion most of the time sorta is your public key can encrypt, your private key can decrypt, right? So the idea here is that with the public key, users can encrypt all over the place. They can encrypt all their secrets up, make them these really nice encrypted secrets, right? And then you just can basically, not that I'm saying you have to do this or should do this, but you can just store literal secrets in public-facing repos because unless that private key gets compromised, it is encrypted and unusable or seeable, right? It looks like Steve confirmed for us that you can use a private key if you want to provide your own. So then what ends up happening is you end up submitting this CRD, which is kind of like a wrapper, if you will. Actually, I guess I'll get to that in a second. So what's basically happening with the sealed secret controller is there's a secret key, and that lives in etcd. Okay, so here's why this thing is not necessarily a replacement for encrypting, and it's solving a completely different concern, right? The etcd cluster is storing, it holds in plain text format, if you don't encrypt your etcd, right? It is storing the private key there. So in theory, if etcd gets compromised, the private key can get compromised, and thus you can now decrypt the secrets. Another key thing to keep in mind, and this is where I'm going to switch into the other diagram just to kind of show you what this flow sort of looks like. Where do I have this one? Sealed secret, sealed secret. Secret, sealed, flow. I think this is it. Yep, okay, great. So what's happening here is users are creating this sealed secret in green. Now, sealed secret, fully encrypted. If I got my hands on that sealed secret, I would not be able to figure out what the secret contains without actually getting my hands on the private key and decrypting it. But the sealed secret controller is doing a bunch of magic. For example, it's taking the sealed secret and it's actually storing a version of it, if you will, as an unencrypted secret inside of etcd. Okay, at least last time I checked, this was kind of the general flow. So again, the sealed secret is not inherently safe in the Kubernetes cluster, right? But the sealed secrets isn't necessarily trying to solve that problem. I would argue, and hopefully, again, I'm doing it justice. Feel free to correct me, anyone in chat, if you have different perspectives here. But I would argue that sealed secrets is doing a much better job of keeping secrets safe outside of Kubernetes, right? Because the general idea here is like, especially those of you doing a GitOps flow, maybe you want to declaratively store your secret in a manifest somewhere, right? You want to commit it into Git. Maybe it's not a public Git repo, but like you just want to commit it there. And if someone sees that secret, you don't want to have to worry about it meaning anything because it's fully encrypted, right? So you're basically running all of the decryption services inside of your Kubernetes cluster, which, depending on what problem you're trying to solve, that could make total sense. But the key thing is, again, you're encrypting yourself at this level, right? Or whatever store really that you eventually store the sealed secret in. But inside of this level, for those of you who are platform operators, again, I'll repeat it one more time. Just keep in mind that you still need to solve for etcd encryption. Because at the end of the day, not only is the sealed secret controller's private key stored in etcd, but there are also copies of the secret itself, right? So again, hopefully it's clear what I'm saying here. Really cool project, really different concern in my mind, okay? So that's a little bit of a summary on sealed secrets. If you get a chance and want to try it out, what's really great about sealed secrets is they're pretty darn lightweight. So you can run this controller in your cluster. You can make their sealed secret CRDs. Just like Vault, they have like a templating thing you can use too. So feel free to check this project out by Bitnami. It's a pretty cool one. All right. Last but not least, and then I'll give you all a break so you don't have to continue to hear me blabber about all this stuff, okay, is CSI secret driver, okay? Now, again, I think a lot of the CSI drivers might still be a little bit like experimental. We'll check in a second, so it's probably good that we're not testing it just yet. But now that you have a primer on how that Vault injection worked, I think you'll find this really, really interesting. Let's talk about this and then wrap up for today. So, the secret store CSI driver. I really like this idea. I think I like this idea. I haven't personally gotten to use it just yet. The general notion is to mount secrets, keys, certs in a pod using a CSI volume. Now, maybe to back up a little bit, I don't know how familiar you all are with CSI. CSI is Container Storage Interface, kind of like how we have CNI. As Kubernetes progressed, all these people started building storage solutions to integrate with pods into Kubernetes. Some people were putting them in their cloud providers. Some people were running them as processes or containers outside of the Kube API server or controller. There was a ton of variants, right? So like we eventually standardize on this notion of CSI, which is an interface that defines things you should be able to do. And that interface can then be implemented by providers. So like taking secrets out of the equation, there's CSI providers for AWS EBS. There is CSI providers for VMware's vSAN, right? It just depends on what you want to plug in. So taking that CSI driver model a step forward, what's pretty darn neat here is taking that into the realm of secrets. So as you need secrets, this underlying provider can go out to a secret store, right, and actually grab that secret and make it available in the persistent volume itself. So the cool idea here is more so that you don't have etcd in the data path of your secret per se. You're also loading it into the containers file system, maybe on like RAM disk or something, right? And in my mind, what I really like about this idea, I guess really the plugins and how hardened the plugins get is really going to determine the success of it. What's great about it is I love the idea of just throwing a driver in and not worrying about other complexities in Kubernetes. Like maybe I use, Vault, and I just want to put the CSI driver in and then boom, it just works. There's no complexity per se with like the mutating webhooks. Not to say mutating webhooks are a bad design, they're great. It's just like, it's a little bit simpler because there's this underlying driver looking for when it needs to satisfy mounting these secrets, and it can communicate with the provider as such. So I think this high level one is just kind of the design, I'm pretty sure, because I think there's an Azure and a HashiCorp implementation. Let's see here. Implementations, or providers, I should say. That's probably a better way to put it. Where are the known providers? Let's see if I can find Vault real quick. Here we go. Okay, providers. So there's Azure Key Vault provider, HashiCorp provider as well, right? So, and these are the only two I'm aware of. So if anyone in chat knows of some of the other CSI secret drivers, feel free to put those in. We should probably, I'm guessing, actually, let's check out Vault. I think it's still like an alpha or something. Yeah, okay, this is an experimental project. So if you all are open to it, I think a whole session, I don't know how mature, again, the plugin is. I don't want to put the provider developers, in the fire here if they're still kind of working on it, but this could make a really cool TGIK, I think. So the idea, again, is with that CSI secret driver setup, you can now add the Vault provider, and then not too dissimilar to what we did with init containers, right? We now have this driver underlying that could actually go in and instantiate the secrets inside of the pod, which is pretty freaking cool. The biggest difference here, again, is that whole front end flow. No mutating webhook, no, injecting containers in the pod. This feels a lot more like a true platform service, right? Because you have these drivers running, they're just waiting for when they need to do work, and they just make it happen, just like the storage providers do as well. So I hope this has piqued your interest a little bit. Again, just take what we did with Vault and imagine moving the concern of getting the secret, storing the secret, all that stuff into this little thing called a CSI driver, which is, again, for me, really, really exciting. So let's see how all this goes over time. Let's see if the Azure one's more mature. I haven't looked. I think someone in chat mentioned the Azure or AKS was maybe using this. I don't know. Maybe you can correct me if I'm wrong. But they have a secret store here as well, provider. So. All right, pretty freaking cool, right? So all in all, we covered a ton of stuff today, everyone. This was really awesome. We went through kind of end to end with diagrams, and I'll put some of those diagrams in the repo if you want to look at them again. But we went through kind of a visual of every kind of default option, and then kind of looked at the ways that you can go even further, right? With Vault injection, we talked about sealed secrets, the CSI driver. All of this stuff is really, really cool. And again, coming away from all this, the thing I want to encourage those listening is really that like Kubernetes is this really amazing, extensible, pluggable system. And the benefit and downside to that is that I can't just come on here and say, here's how you do secrets, right? This isn't some turnkey platform where like they're just there and there's one way to do them and that's it, which is awesome because all of a sudden when you start working in a financial services context, the secret requirements are different than when you go work at your startup where you're trying to just pull some database credentials in for your Postgres system, right? Like it looks different in different places, and we have all those extension points in Kubernetes, which is so cool. And I love how the ecosystem around secrets is finally starting to really harden and come to life, right? So again, I hope that kind of excites you. Know that this is really a journey. It's all about just like, how can I make this a little more secure? What problems should I solve for? Try not to boil the ocean, right? Maybe just encryption at rest is fine. Or maybe you're at a point where like, you want to go implement your own KMS plugin, right? Who knows? But you just have to kind of gauge that and know that you have a lot of options, and how your workflow is and how you want to provide secrets at a platform level or an app level is really going to dictate which of these options you go with and how you implement it. And that's about it for today. So I hope you all really had a great time on this session. I had a blast. Chat, you were super interactive. So thank you so much for helping me fix things and, hopping in and doing a great job giving some extra context. This was a really, really awesome session. We'll think more about a future CSI secret driver session too. I saw a couple comments in there as well. So as always, everyone, super, super awesome getting to do this with you all. We'll catch you next week. Joe or Duff will probably be back online. We'll see you then, okay? Cheers, everyone. Take it easy.